Today we are going to discuss about classes and objects. Uh, and yeah, Kotlin classes are very similar to Java classes. So, as you know, classes are blueprints for objects. This is a very good example where you can see this is a blueprint, meaning you know where in this house, where the family room is going to be, where the kitchen is going to be, and we are following the same blueprint to build all these houses. So this is a class and these are objects. I will also say that instances wherever you see are whenever you see when I use a word instance, that is nothing but objects. So every class has many instances or objects, and there will be some behaviors that's going to change. So let's see, like methods. This is one example. Another example is shapes. Let's say shapes is one class, and in that we will have a circle or a rectangle or a triangle or anything. So these so shapes, if it is a class, it will have get area as a method, and we can use the same get area method for all these objects. We can use that method, but we can change the formula of that method for each object, but that method is still accessible by these objects. Classes versus object instances. So let's say this is our house class. We have data, house color, number of windows, is it for sale, and we can update these behaviors for objects. Yes, like the blue house is for sale, or orange house color can be updated to yellow house. So these types of updates can be made. Let's say there is a shape and we have a triangle. Area of the triangle can be updated. And if you see in IntelliJ A, so this is our main program, and in the main program, a class, how you can add a new class. I don't know how many people are familiar with this. Right click, so you can see new here. First, let me over the project. I think in the functions lecture video I have shown you how to create the new projects. New project, and you have to make sure you're clicking on Kotlin here, and you can create new projects here. Now I'm not creating because we have enough test projects here to sample ones. So now this is our new project, and when you click on your main and right click, or if you're working on the Mac, you can, right, control click, you get this new option. You can create any class. As we are working on the Kotlin, you're going to create Kotlin class. This is how you create new classes. I have created a couple of new classes like student, animal. So these are some new classes. This is how you are going to create class. Once you have created the class, you can add these instances. So now this is a student, and these are all some constructors. So like, sorry, input parameters that you can provide. It can be either like this class student, you provide a couple of input parameters, or yeah, as you wish, like there is a one input parameter or two input parameters, or sometimes you don't even have to provide any input parameters. It can be something like this without any input parameters. So this is another type of constructor where you can create without any input parameters. This we have already discussed in functions as well. I hope you watched our last lecture video with the functions. So this is how you create new classes. So class name, whatever you want to use, and the input parameters. So here, this is the name, and what is the data type is going to be string, a name, age, and what is the data type going to be integer. And you can create these instances, like you can provide this student name, it is a string, and age, it is an age. You have given the variables, and if you remember, when you so if you remember, if var variable, it's, you can update this variable name, or if you have provided val, this is like a constant. You will not be able to update it anymore. Here I'm going to provide it as var, because I'm going to show you in objects how you will be able to update the names. Similarly, animal, and I have given you, and make sure that the class name is different from this variable name that you are creating. And a string, it has to be I mean any data type, it can be a string, or in this example we have taken integer, or students GPA. If you want to add here, it can be a double. So depending upon the data that you are going to provide as input, you need to decide what data type it is, what data you are going to provide as input. You can decide what data type it can be. So these are the classes. This is how you will create a class. And let me show you the variables or instances how you can create. So let's see the animal class. In the animal class, you have a name string that you need to provide as input. This will be something like this: animal, animal. So this is your class name. Whatever is here, this is your class name. This is the variable that you have chosen. And you can provide any string here. It can be a bear and a bird or a cat, anything. Suppose if you don't provide this, if you don't have this, so you can still print it out. uh, okay, so you can print it out. I don't understand, you should have gotten bear here. Print out animal name bear. Yeah, now I remember. Whatever you provide it here, but you didn't provide any animal name. Animal name, whatever you provide here should be here. So what you provided is a bird. This is one way of creating your object, a bear. If you want to update it, as we have seen here, the variable, it is not a val, it is a variable. When you do it, I ran it earlier before I came to this class. If you are able to let me know why I'm getting this error, it would be helpful to me. So you get the idea. This is the class that we are using, and these are the objects that we have created. For the animal class, these are the objects. The animal, this is one object. And for the student class, we can either provide input as string, age int, or we can provide here John 15. But then if you provide it as, if you comment this one out, the name will not be updated to Kate. If you don't provide the comments here, if you don't comment it, if you comment it, the name would be printed out as John with age 15. If you comment this one out, the name is going to be updated to Kate. Still the age would be 15. And this is one object with one instance. I mean one object or instance. This is another object. These are different types how you can provide the input parameters. You can either provide it as just the string and the number, or you can provide the variable name here. Name equals to John, age equals to 19. This is another way of providing the input parameters. So this is how you can visualize class and objects. This is house class, the data, house color string, like how in our student class, the data student name, age number we had, like that. Is it for sale? In the student class, we could have added, is the student senior, something like that. Now, define and use a class. So class house, where you can see like how we have used variables or values. This is val, color string white. Number of windows int 2. So in the class itself, we have provided these values. or we could have used, we could not, we could have skipped all these input parameters, but still that would be our house, class house. This is what I was mentioning. You can create a class with no parameters, like how in the functions lecture video we have discussed. There can be a function with no input parameters, or there can be a function with single or multiple parameters. And in the parameters as well, there can be default parameters or required parameters. So this is how you create a class with no input parameters. And the examples that we have checked out here are all the classes with input parameters. I have 2 input parameters here. Here I have 1 input parameter. Sometimes there can be classes with no input parameters as well. I think in this class only we discussed about the shapes, where circle, we create a class circle with input radius, and we can create a class circle without any input, and we can add a variable radius to this circle. So this is class A, a value, and class B. When you have objects here with the class A without any input parameter, this is how you create it. The constructor, these are some constructors. Class B, if you provide an input parameter integer here, then it should be 12. But remember that if you try to print bb.x, a compile error will be displayed. Class C, value integer, here you don't have the input value because you have mentioned the constructor like C into C equals to 42 clearly. So if you want more details, we can go over here. Like the constructor for class B has 1 input parameter, which is an integer. Because the parameter is not marked as variable or value, the variable x does not exist outside the scope of this constructor. We need to definitely mention that this is a value. If this is not mentioned here, we will see the compiler error. I'll stop here. Any questions? Here we can see the compiler error because we did not mention it as a variable or value. Now let's discuss about default parameters. Just like in the functions where we have discussed about default parameters, meaning we will give a default value, like for width we have provided a 20 value, for height we have provided a 40 value. So these are default values. Suppose if we don't mention it here, like you see box 2 equals to the box, this is the class box, this is our object. So box with the length 100, and it doesn't give any values for the width or height, but that means by default width value is 20, by default height value is 40. So these three are same. You can write either like this, or you can code either like this or like this, and even you can change the numbers here. It doesn't have to be 20 or 40, but here it is the value. If you change it to variable, you can even update these values. It doesn't have to be same. Similar to our functions, in functions also we discussed about the default parameters, how you provide it, the input for the functions. How in the functions we had a keyword function, here we have the keyword class. Any questions here? Now, let's look at this primary constructor. Declaring the primary constructor within the class header. Like in our example, how we have added the primary constructor name string, animal name string, for the student age integer. How we have added it. This is This is the primary constructor. This is equivalent to if you have just a constructor without any input parameter here, you can add a new constructor here. This both you can either code like this or code like this. This just saves you lines. Any questions? Initializer block. Any required initialization code is run in a special init block. Sometimes we can add multiple init blocks as well. So for the primary constructor, as we discussed here, this is our primary constructor. In here you can see the init block. In the primary constructor body, we have this initialization block. So one example, here we didn't go in detail about the initialization block because we were focusing more on the primary constructor. One example of initializer block is class square. This is our class name, and input parameter would be a value, side, and what is the side going to be? Integer. Remember that it is going to be a integer. And initialization block, a print ln. What are we going to print here? Like area, side times 2. And what is going to be printed out? This is 20. And remember, here we haven't provided what is the side value is going to be. After the initialization block, you can provide whatever the square side is going to be. It can be 10, it can be 20. Here we can add, when we are working on the students class or in the main category. In the students class, we can add an initializer block. Now, discussing about multiple constructors. Use the constructor keyword to define secondary constructors. If you want more than one constructor, you can always use the constructor keyword to define secondary ones. How we are going to use this keyword? Now, another secondary constructor that calls the primary constructor. So, we are going to use this and this more reading. If you want to do, you can get to this link. Here, very clear documentation is shown. Now, this is the class person, or there can be a class empty. So, if the class has no body, every class, if it has no body, earlier in the class students we had bodies that is going to show us what is the student name, it's going to be a string, what is the student age, that's going to be another string integer. Those will be under class body. If you don't need a class body, if you see here, this can be a class person as well, just without the curly braces. Now, as we were discussing about constructors, class, person, constructor, first name, string. Here, we have provided the names in main class. Instead of that, you can provide the name here, the first name, string. Class person, first name, string. So, these are multiple constructors. And how the initialization is going to be inside the class block. So these are secondary constructors. Already we have a class person, and now we are going to use the constructor here. Class pet, we have one, and there is going to be, we are going to use owner person. And when we have multiple constructors, we can use this here. So we have the class person with a value, name, string. Now, for the person, this is the class, these are the objects. Value child, and this is a mutable list of this person. The person will have multiple children. So for this person we have objects here. So now constructor, the constructor is providing you the string, name, and parent, the person. So for this class, when you are mentioning the person class, you are going to use this here. This meaning the person class here, this name. Parent, we are going to add this object to this class person. How you are going to do that? Add this. This here meaning the person here. So for the multiple constructors, this is how you are going to use this keyword this. Any questions? I want to see if there are any raised hands. Yes, Joshua, what is the question? You are on mute if you are asking the question.
Oh no, I didn't have a question. That was from when you were asking if we were familiar with Java classes and objects.
Oh, I'm sorry. Uh, okay, I'm trying to see if anybody else would like to join. Okay, this is another. So using this is also present in Java. I mean, using the keyword to represent the parent class for the object, we use this. Going back to our classes and objects, inheritance. We'll go over this in a couple of slides. Multiple constructor, one example. So this is our class circle with the input parameter radius, and the radius can be int or double. Here we have used input parameter double here. The constructor name string. So for circle 1, let's say circle 1, this is the circle. Radius that we have provided is 1. Diameter, and this again for this circle, the diameter that we are going to provide. Now println in diameter constructor, initializing area. How do we calculate the area? We need the radius. So we are going to use this constructed diameter divided by 2. Suppose we have provided the diameter, this is how we are going to provide. And this is another circle with radius 3. This is how you will show. This is the circle with the input parameter 3. And now we have two constructors in this circle. One example of multiple constructor, and how we are using this keyword here. Now, properties in classes. We define properties using val or var, like how we did in this example. So using var or I have used all variables here. We can use var or val. And the difference between var and val we discussed, I think, in the week 1. If it is a constant, like a pi value or any value that once we define, you're sure that you're not going to change it, you can use val. And if you are going to set it like in one class, it is going to be like in the example that we have seen here, the student name is John, and again we are going to change it, the student name, like a student 2 name is going to be Kate, then we'll provide it as var in the class. And how do you set and get these values? Just using the dot notation. In this example, like how we are trying to get this student 2 name, just by using the dot notation. How you are going to set the name? This is using the dot notation equals to Kate. So this is how you will set the value, and this is how you will get the value using dot notations. There'll be some examples here. So accessing with a property name, println person dot name. So you are getting the value. And how do you set the value? Like person.name equals to Zoe. Now to make sure that when you are trying to set the values, it is only a var, not val. Otherwise, you will get error. Or you can create your own custom getters and setters. So overriding using this method for a property or this method to set values for a property. Now class person, this is your class name and these are your input parameters, first name, last name. And when do you use a get method? When you are trying to concatenate those two strings. Get full name, that is going to be a value. You have decided that you are not going to change it. Value person is going to be first name and last name, Jando. And this is how your output looks like. And this is your how you are going to code custom getter and custom setter. If you have a full name, setting values, what is the first name value is going to be whatever the component is at 0 position. This is a 0, like arrays, the first one is going to be 0, second one 1. Any questions until now? Now let's discuss about functions in classes. Classes also can have contain functions, like how we discussed in the last class. It is created using a fun keyword. It can have default or required parameters. If you have if you don't have any specific return type, you can mention unit. Unit is equivalent to void in Java, and by default it is going to be a unit. You need to mention if some return type, if there is some value going to be returned, you need to mention it int, double, string, or something like that. If you don't mention anything, by default it is going to be unit. Now let's discuss about inheritance. Inheritance, it's similar to Java. We have interface, class, subclass, and there is going to be like a superclass, a subclass. This is Kotlin has a single parent class inheritance. Suppose if you have mentioned any variables, methods in your class, all your subclasses, objects will inherit those methods and variables unless you restrict it. Kotlin has a single parent class inheritance. It will have one parent and we can call it a superclass, and all the subclasses will inherit the members, methods, variables, whatever are declared in the subclass. If you don't want to be limited by only inheriting a single class, you can use interfaces. That's the difference between superclass and interface. Superclass, there will only be one superclass, whereas you can use multiple interfaces using extents. Now, interface provides a contract all implemented classes must adhere to. So, how for a subclass there is one superclass, and for the superclass there will be there can be multiple interfaces, not necessarily one. And whatever the contracts interfaces pose, all these classes should maintain. It can contain, the interfaces can contain method signatures and property names. One example are how the formatted, how it should be formatted, interface and name, something like a class, student, or college, and its body. Let's see the example here. Let's see interface shape, and there can be classes like circle, rectangle, triangle. And in this class, there will be multiple objects like circle 1, circle 2, circle 3. So function compute area. This is a double here. And how do you compute area? This in this class, in circle class, you'll have like pi r square. If there is a rectangle class, you can override a fun computer area as length into breadth. So that's how you're going to use interface functions in your classes. Extending classes. Any questions until now? To extend a class, create a new class that uses an existing class as its core subclass. There are some examples so that we can go over here. Add functionality to your class without creating a new one, like this. Now this declares a class A, and how do you, no, not this one. This has to be, there has to be a keyword called public. When you have a public class A, you can create subclasses like this. Here we don't have a public here, so we will get that A is final, it cannot be inherited from. Kotlin classes by default are not subclassable. Use open keyword to allow subclassing. Sorry, not public, you need to use open keyword. Properties and functions are redefined with the override keyword, like how we have added override keyword here. Like that you have to add override to redefine your functions. And to create subclasses you need to use open. I'm sorry, earlier I said public, but it has to be open. Open keyword. Public is for methods, not for classes. Now when you declare a class A, this is not open. Now by default this is not open. You need to mention open to create a subclass, like this. Open class C, subclass from C, class D to D from C. And one more thing, this class doesn't have the parameters. Now overriding, must use open for properties and methods that can be overridden. Otherwise you'll get a compiler error. Like open, if you don't, like in this example, we got a error. Must use override when overriding properties and methods. Like in this example, like how we have used override function for all methods and functions. When you are using it in a subclass, you need to use the keyword override. So in the class, if you use this keyword override, in the subclasses, you don't need to use override. So in this interface, you have shape and a function compute area. In class, you have overridden function using this keyword. Now for your subclasses, you don't need to use override. Unless here, if it is mentioned as final here or here, then you can't use override keyword. Now, let's discuss about abstract classes. Why do we need abstract classes? If we don't need, if you don't need any instantiation, then you use abstract classes. You cannot mark it with the open keyword, because if you use open keyword, then you can have subclasses, right? So for the abstract classes, you cannot use open keyword. Similar to interface with the added ability to store state. Properties and functions marked with abstract must be overridden. Definitely, if you don't use overridden, this is abstract class, it is more or less like an interface. This is one example. And you need to mention the keyword abstract for the abstract class. If you have a keyword, now abstract value, kilocalories, abstract value, name, function, consume. What is this function's use? What are we going to do with this function? We are going to print I'm eating, whatever the name is going to be. Now let's say here the value, it's going to be string, right? If you have a pizza, then it's going to be I'm eating pizza. If you have anything else other than pizza, ice cream or something, it's going to be in the main function, it's going to be I'm eating pizza. Let's say in our example, in the main, if we have name is having fun, it can be, if the class is student, it's going to be student is having fun. If the class is animal, it's going to be whatever the animal name is going to be, bear is having fun or something like that. So if you are using whatever the function name is going to be, like a pizza, here the class name is pizza. In our example, it could have been a student or animal. I'm eating pizza. The function here, consume, I'm eating. So we have discussed about interfaces, classes and subclasses, and abstract classes. When to use which one? So if you have a broad so many behaviors and types, then it's better to use an interface. If the if the behavior has to be specific, meaning like in that blueprint, is it going to be for sale or not, the specific types of behavior if you have, then it's better to use a class. And if you need to inherit from multiple classes, then you have to refactor the code. You don't need interface or subclasses, you just need to refactor it. Now let's discuss about extension functions. Any questions until now? Extension functions. Add function to an existing class. So initially when we create a class and we have already specified some functions, it's over. Then after, if you need to add functions, you are going to use extension functions. The format of extension function is going to be like this: function name, function keyword, class name and function name. So appears as if the implementer added it. It doesn't actually modify the existing class. It's going to be an extra function. For example, here we have a function consume. If you need to add an extension function, you're going to add function pizza dot function name, like let's say print something, and parameters, input parameters, you need to provide something, and in the body you can add print ln and whatever the function that you are planning to do, the body of the function. Let's see, this is one example of extension function. If you want to check if a number is odd or not, function integer is odd, this is the function name. And by looking at this only, you can tell, right, what is the return type is going to be. Is it going to be int or boolean? If we are going to check if a number is odd or not, so it's going to be yes or no, boolean. Now body of this function contains return this meaning whatever is the class. Now we are going to provide the number here. Return this mod 2. If it is going to be 1, then it is odd. Otherwise, it is not odd. Extension functions, we need to use this most of the time. So this is a very useful function. Call is odd on an initialization. So in your main program or in the class programs, you can add initialization and just say 3 is odd, meaning this 3 is this here. When we say this keyword here, whatever the integer that we are providing here, this is odd. Why do we use extension functions? So if you want to add functionalities, then we use extension function. Any questions about extension functions? This is a very good example. If you understand this, you'll be able to implement extension functions like this. Now, special classes. We are going to discuss about a couple of special classes here. one type of a class called data classes. Suppose if you are trying to store some data, we are going to use a data class, and as the name suggests, this keyword data has to be used. Mostly we are going to generate getters for each property, like a toString method, meaning converting an integer or double to toString, or if we are checking if a particular value is equal to another value, or get hash code. How many of you are familiar with hash code? So hash code meaning when any variable is instantiated, it will have its own value called hash code. It's like some number 23456 or some number. To get that particular value, we will use hash code method. Then copy. If you are trying to copy some value, these are all different methods that we can use in the data class. And destructing operators, meaning if you want to free up some space, you don't need a variable that you have already instantiated or declared. If you don't need it anymore to maintain your garbage collection, you use some destructing operators like a final or empty. When you're using those operators, those are some examples of destructive operators. So when you are using these methods or these operators, the data class is perfect for that. And what is the format of it? Like a data class, and whatever the name of class is, like a student or whatever functions, like a circle, the class name and parameters list, whatever the parameters like integer, what you are going to use here. If you are trying to convert a string integer to string, then here the parameter list is going to be a integer value. So here, like you see, data class, the class name is player, and the parameters, a value, name, it's going to be a string value, a score, it's going to be an integer value. How do you use it? Value, the first player, player's name and score, println first player. Or you can you can convert this to a string, val first player integer, convert integer to string. This method you can use. Or you can check if the player Lauren 10 score is equal to another player's score. You can check that. Or you can get the hash code values of Lauren, and whatever the value for Lauren was some constant number, it would be displayed. So like that you can use a data class. This is one of the special classes type. Now pair and triple, like the name itself suggests, these special classes are predefined data classes. These are also data classes. A pair data class will store, like the name suggests, 2 pieces of data. Triple will store 3 pieces of data. Let's see some examples here. Like Harry Potter and J.K. Rowling pair, it stored 2 pieces of data. Triple meaning the with along with the year, 3 pieces of data. So these are data classes with particular specifically how many data values are stored here. Pair 2. So pairs special 2 variant lets out, like how we have a comma here. If you want to remove these values, you can use pair 2, like Harry Potter to J.K. Rowling. Then we can remove those values. Book author 1 and author 2 are pair, like Harry Potter to J.K. Rowling. This is book author 1, book author 2. Now Harry Potter to J.K. Rowling. And for maps you can use it. Now 1 to X, 2 to Y, and 3 to Y. Enumeration classes. Still we have 5 more minutes. Enumeration class, I think you might have you might be familiar with the enumeration class. So similar to Java, this is storing some named values like name1, name2. In this example, this is the format. Let's go over some examples in the next slide. This is your name, whatever the class that you are using. Use this to require instances of several constant values, like this dot name, meaning that classes objects dot names. See this example. Now value r some integer value, g some integer value, b some integer value. We can use enumerator class color. This is the keyword enum. This is the class and class's name. You can use these values and print it together. 25500. All these values you're printing it together. Object, as we were discussing about all the classes, now object is uh, some instances of that class. Sometimes if you want only one instance of a class, like how we were discussing, in one class there can be multiple objects, right? If you want only one instance of the class, what do? Use the object keyword. If you use, like how we were using open for the class, that's the keyword. To create subclasses, to create one object class, we use object keyword. So instead of class name, here we are using object calculator, and we are using this function add. Now println calculator add, similar simple function, just adding two integers. Okay, I will stop here for today.